Hi, welcome to the International Space Station Flight Control Room. I'm Brandy Dean. I'm a Public Affairs Officer here at NASA at Johnson Space Center, and I've got with me today Jason Dyer, who's one of our robotics flight controllers. Jason, thanks so much for joining us. You want to tell them a little bit about yourself?
Sure. Good morning. My name is Jason Dyer. I've been a robotics flight controller down here at NASA for just over 10 years, originally from Canada in Ontario. And I've been loving this job ever since I started.
What are some of the things that you do as a robotics flight controller?
We do a lot of planning for the robotics here on the space station. We train the crew on how to use both the Canada arm and the activities on the ground support that. We do on-ground training, and then obviously we continue our own certification, both for our backroom certifications and for up here in the flight control room as well.
And just in case, I bet they've looked it up, but why don't you tell them what the Canadarm is?
So the Canada arm, it's actually the second Canada arm. The first round of Canada arms flew on the space shuttles, and they were retired with the space shuttles a few years ago. But our second generation arm now is fully maintained on the space station and allows us to walk all over the space station using the mobile transporting system. And along with that and SPDM or Dexter, we do robotics activities to repair on-orbit repairable units.
All right, so I think y'all have some questions for us now.
Uh, yes. What inspired you to choose your profession and work at NASA?
That's a really good question. I've been looking at the stars since I was like 6 years old, as I'm sure a lot of people do. I had a telescope, I think, for my 7th birthday, and I was about to do anything I could possibly do to get down here into a space program, whether it been this one, the space program I joined in Canada that sent me down here to this international partnership, and whether I support it on the ground or ultimately become an astronaut who's capable of flying up there, I was just happy to be here.
Next question.
Can you describe a typical day at work? Nothing big happening, I guess, just an everyday on the job kind of thing.
You know, I really wish it was the same 9 to 5 thing every single day. One of the really interesting things about this job is that it's so dynamic. I don't think I could cut and paste one day or even 1 week's worth of activities to make them the same every single day or every single week. My days can be dynamic in the fact that I could be here in the flight control room that you see behind me. I could spend an entire day here. I could be out at the neutral buoyancy lab helping train astronauts in both for a spacewalk or using the arm.
And the Neutral
Um,
Buoyancy Lab is a giant swimming pool, basically. So that's pretty cool.
Yeah, it is. It's really cool to see. It's absolutely huge. My day could be over in the simulator, the space station simulator, which we all work together as a big, huge team, supporting on-orbit operation type simulations. Or I could be sitting at my desk writing procedures for the next upcoming event.
All right, thank you.
Hello. What are some life-changing things you learned in your profession?
That's a great philosophical question, but honestly, you've really got to enjoy your job. You're gonna have some bad days, and I don't care what job you have, you're gonna have some bad days. And as long as you love your job and you love what you do, those bad days go by fairly quickly, and you can just enjoy the stuff that you're doing that day.
Thank you.
You talked about the neutral buoyancy lab. What are the differences between being in the neutral buoyancy lab and being actually being in space?
A lot of water. No, honestly. It's the best thing. Obviously, we can't truly create zero G here on the ground. So the next best thing we can do is in the neutral buoyancy lab, we can balance ourselves between wanting to float to the surface with some weights, and that balance basically simulates the best that we can do for zero gravity, and that allows the crew members to train so that they can get the feeling of how they're going to have to constrain themselves when they're doing activities or how they can move along the truss while they're outside. So it's the best we can do. It's a little bit different. Really, the best people to ask for that would be the crew members once they've come back from the station and see what they could say as the difference.
Um,
What did you do during the 11 shuttle missions and stage activities, and which do you consider to be the most successful?
So those 11 shuttle missions spanned 8 to 10 years, and the stage missions as well. I have a lot of fond memories of some of the shifts that I've done, mainly supporting installations of modules, some of the solar arrays. I was on console for those sort of things. I think the three most memorable events that I have is one, back early, we were unfurling a new solar array that was going to give power to the station, and it got stuck. And we had to re-coordinate through the entire team, how we were going to fix this thing, and that was 17 days of non-stop operations. That was pretty exciting. The second one was probably when I was in charge of delivering the new cupola work environment. It's basically a giant observatory here on the space station. The crew loves it, and most of us love it here on the ground because it provides some excellent photos of the Earth as they go by. And it was my robotics team that installed that where it currently is. That was very exciting for me. And I guess the last one would probably be part of the emergency team that fixed the pump module 2 years ago. It's a very dynamic time when we've got issues like that. That's what we train for. And I was very proud of my team and how fast we were able to recover that.
What is the scariest situation you've ever been faced with?
So that last one was probably pretty one of the worst situations we had. It's hard to explain to people that aren't in this environment what's the situation we're in. We're basically working 15, 16-hour shifts nonstop, trying to get all these products done that we usually normally have weeks or months to complete, under the understanding that we can't make an error. All of this while we're one failure away from having to shut down the space station and come home. And I think it's not so much scary as in challenging. And it's that challenge that really drives a lot of the flight controllers here to do their job.
What is your opinion and or personal view on the future of space exploration?
I'm always happy to hear that we're, most countries or most agencies are pressing forward. Obviously, there are difficulties right now in setting priorities and stuff like that, and each country has their ideas of what's the highest priority. It is nice to be here in an international setting where, as we have, I believe, 16 countries involved here, each one of them is still providing some sort of resources to keep this program going. And as long as we keep that philosophy of just keep going forward, I think we'll still have a successful program, at least globally.
What applications might your work have in the public sector?
That's a really good question. You can't really go to school for flight control operations. It's a gathering of skill sets that you learn both at school and in industry itself. I think if I were to leave flight control here, some of the best skills I would probably transfer out would be management and integration, would be a lot of the activities I do on a regular basis. Operational concepts would be another good one that would go to other industries quite easily.
What is the most complex robot that you've made or designed?
I'll be honest, I haven't actually built a robot. My background is in aerospace engineering and material science, but I have done program management and integration in the past, which gave me the basic skill sets I needed to come into this job in the first place. The most complex robot I have seen is the one we're currently working on here in the space station. Thousands of lines of code. And it's just incredible to see the amount of software and hardware that's required to get these robots to go.
Can you describe what it feels like to be in a buoyancy pool?
Not far off. I actually certified scuba diver, and a lot of the activities we do, even privately or away on vacation, transfer similar to what we see in the neutral buoyancy lab. It's almost like floating. It takes a little bit of a getting used to of not being able to trust that when you let go of something, your feet just go to the ground. Your body doesn't understand which way is up and which way is down, and if you close your eyes, you really can't tell. So it's quite exhilarating. I quite enjoy it, which is why I got certified as a scuba diver. And I would imagine that being in the buoyancy lab, it's very much similar there.
How do you think NASA will go about conserving fuel for the trip to Mars by 2030, and what fuel will be most efficient for this trip and why?
That's a really excellent question. It's really hard to answer. It will all depend on what's going on at the time and what priorities and when we do it. If we look at, say, the space shuttle, the solid rocket boosters were using one type of fuel, then we went to the hydrogen-oxygen mix for a different type of fuel, and then when we were on orbit, we had a third type of fuel with the thrusters. I would imagine the Mars mission would be similar depending on which stage of the activity that we're in. It would also depend on when we do it, whether we develop new technologies or new ideas on how to produce thrust or whatever we need to do. So to give you an exact fuel of what we would use would be very difficult right now. But I think it's an excellent question. I'm sure many engineers are down here thinking about the same thing right now, too.
We actually have a group here at Johnson Space Center who is working on what they call in situ resource utilization, which is basically a big fancy way of saying living off the land. And hopefully they're looking into ways that we might be able to get the fuel that we need where we go. So if we can find a way to produce the fuel that we need to get back on Mars, then we don't have to take as much with us when we go.
Thank you.
Before you're saying how your eyes kind of like disagree with your inner ear, and you see something that you don't really it doesn't really feel the same way. So like if you're upside down, you'll see as if you were like you think you're falling, but your inner ear, do you kind of just feel like you're just floating around? You don't really feel like you're going down or anything like that. You just feel constant, I guess you could say.
So I think your question is borderlining on what it's like to get vertigo, which happens both when you're on a very tall building looking down, and actually you're exactly right, it happens when you're in a zero gravity or even scuba diving at the same time. It's basically your eyes thinking or not being able to determine between where you are and where you should be, and your body, your inner ear, not sensing, not lining up with that intuition. And unfortunately, getting vertigo, some people handle it better than others, but yeah, you can feel kind of queasy if your body doesn't handle it well.
All right.
Hello again. I understand you work with a lot of technology, so I was wondering what you think of the recent massive solar flares. What kind of concerns they might have to you?
Well, the sun's been all around for quite a long time, and I'm sure this is part of its solar cycles. It's always spitting out stuff. It's always having solar flares. I don't work personally with those solar flares, but the keen interest that I do have in orbital mechanics and stuff like that. I'm not overly concerned about them, but I am monitoring just out of pure excitement of what's going on.
Okay.
What do you do during extensive simulator training?
It's a really good question. So part of our training down here is to prepare ourselves for contingency or bad days here in operations, whether something fails or something isn't going right the way we expect it to. And then we use our simulator training to basically simulate our days, and then we have trainers in the back room that will cause things to fail or cause activities to go wrong, and they are building our skills to learn how to react to those in the shortest amount of time possible. and some days can get pretty tiring. We'll put it that way.
Hi, I'm going to be majoring in electrical engineering next year at Penn State, and I was wondering what kind of jobs are available to electrical engineers at NASA.
There's a wide range of jobs here at NASA, along with many of the agencies around the globe. Skill sets, like a specific engineering type, just to give you an idea, here in robotics, we have mechanical, aerospace, electrical, biomedical, we have mathematicians, we have one geologist. So it's not so much the actual degree that you bring with you, whether it's electrical or mechanical, but more the skill sets that you've learned or are willing to learn when you come here to apply for the job.
All right, thanks. I also have another question. What differences have you noticed between Canadian and American space programs?
Size and scope. Really, I mean, NASA's budget for their space program budget is probably about 50 times the size of the Canadian one, but I mean, the country's larger as well. I mean, you're talking a population of 300 million versus 30 million. It also comes down to priorities. I find that Canada spends a lot of its resources trying to partner with other space agencies such as NASA or the European Space Agency to try to build towards bigger projects, whereas NASA has the capability of doing a lot of projects by itself. Both of them are pushing forward in space development, and it's really just coming down to the scale of that push and the priorities of what's important to each agency.
The first space station commander for the Canadian Space Agency just actually wrapped up his time at the space station and landed back in Kazakhstan on Monday. Chris Hadfield.
I'm just really curious to know this, but did you ever witness any accidents during your time at NASA?
Honestly, no.
All right, another question. What planet would you like NASA to explore after Mars?
After Mars. That's a tough one. I'd probably go further out. I'm going to say I'd like them to explore Pluto.
All right, one more question. What is your favorite astronaut food?
Sorry, favorite?
Astronaut movie?
Astronaut food. No, astronaut food.
Food.
Oh, astronaut food. It's really interesting to see what they take up on orbit for food. Most of it's dehydrated or canned. And I think of all the astronaut food I've tasted here on the ground, surprisingly, I most enjoyed the apple slices.
Thank you.
All right. Do we have any other questions from East Stroudsburg?
I think we got someone coming up from the back over here.
Okay, excellent. Looks like we finished all of our 16 questions. Looks like these are kind of off the cuff. So our next question is coming from someone. And who's that student?
What number is that? Okay, she's coming up.
Okay, excellent.
Yes. Okay, my comrades in the back would like to know if you believe in aliens.
Really good question. I'm not sure whether belief or statistical possibility is the same thing, but I would hope that in all that space out there that there's at least someone else just to compare, I think, of what goes on.
Okay. And also, how does scuba diving compare to being in space?
Well, having never been in space right now, I would hope it was somewhat similar. But I love scuba diving, and I hope one day it does prepare me to go into space, so I hope it is very similar.
We have a group that does what we call analog missions, which is kind of simulated missions on the ocean floor to practice for going on planetary exploration missions in the future. It's called the the NEMO missions, and we've had, I think, 16 of them. So I think a lot of the astronauts say that that's really helpful for training.
Okay, thank you.
Okay, I think that was all the questions.
All right, thank you guys so much for all those questions, and thank you, Mr. Dyer, for coming and actually doing these question and answer and this little interview. We really appreciate your time. Are there any final words you'd like to say at East Stroudsburg?
I know I've really enjoyed talking to you people, you guys, and a lot of excellent questions. I'm glad you guys are thinking really hard about this stuff. I hope I've been able to at least get you interested in the space program at least as much as I am, and hopefully one of you guys down there will end up down here working at NASA with as much interest in this program as I have.
Thank you.
Thank you.